Okay, guys, we're gonna go ahead and get started. I think I need to share my screen with you. So today I want to just do a few, kind of as many as we can, FRQs. This is the 2019. It's called like their practice exam. Now they released this like before the coronavirus hit, so they released this back in I think December or January. But it's still really the most recent practice exam they've made. So this is a full, 6 questions. It's not going to be exactly like what we have. But I think that, doing all of them, right? What I saw, I kind of posted this in that hint yesterday that the director of AP Calculus for the College Board had basically said that, if you do the 2019 exam, what she was kind of saying, and I'll pull that up right now if I can. All right, here we are. So this is from the Google Classroom that I posted, this kind of 2019 exam. And so what she was saying is that, they might take, this is a traditional question, right? Like parts A, B, C, D. And for that 25-minute question, that first question, they might take this stuff. They might get rid of like, one of these. So like maybe they get rid of like part question C or something. And then that they might add in, something from this question or something from this question to kind of combine them. And then that the second question might be a lot more traditional. So she said for the second question to really look at question 4 and to really look at question 6. And those are good representatives of that second question. So I think this 2019 exam is definitely something that we want to go over. I'd encourage you guys today, if you have some extra time, to look through it. And then right now we're going to go through what's different. So that was the 2019 exam that students actually got and received. This, even though it says 2019 exam, this is actually, if coronavirus hadn't hit, this would have been your guys' like mock exam, practice exam. And really, I'm not supposed to post this anywhere. It's supposed to kind of stay more secure. So I can't post this entire file for you guys, but we can go through and practice it and look at it. So this says the rate at which cars enter a parking lot is modeled by E of t equals 30 plus 5 times t minus 2, blah, 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 blah. The rate at which cars leave the parking lot is modeled by differentiable function L, and selected values of L are given in that table above. They're both measured in cars per hour, and time is in hours after 5 p.m. So that's something that is kind of, or 5 a.m. Something to just kind of realize. That means that, like, right, if we have t equals 2, it would be 7 a.m. If we had t equals, say, 12, it would be 5 p.m. And so just kind of counting that. And then it gives us this interval from 0 to 12. So noticing we didn't get anything about like increasing, decreasing, so we're probably not going to have any any sort of approximations, like over or under approximations, but we did get an interval, so you never know, we might have um, an absolute max and absolute min. I'm going to pull up my calculator just in case we need it. Yeah. Okay. So it says, what is the rate of change of E of t at time 7? That's our first question. The rate of change of E of t at time 7. So as soon as we see rate of change, that's derivative of E of t. So they just want us to do E prime of t. And then after we get that, then we can do E prime of 7. And really, you could just jump ahead to E prime of 7 if you wanted to. So on our calculator, write derivative with respect to time. And then we're just going to type in our function. And so it's 30 plus 5 times t minus 2 times t minus 5 times e to the negative 0.2t. And you can do this and write that out, or you can also just put control at times 7. So we get 6.1649. Right, and our units would become cars per hour squared because we did a derivative, so we're adding on a per hour to our unit. It did say indicate units of measure, so you're, either it's 2 points or sometimes, in this case, it was just 1 point, kind of all or nothing. If you messed up your units, you didn't get the point. Now, I like to write E prime of t first, especially for non-calculator questions or for, if we have like some kind of like an f of g of x, you definitely want to like do the derivative by hand first, like f prime of g of x times g prime of x, doing the derivative by hand first. But in this case, with an equation using our calculator, we didn't really have to write that first. Okay. Next, how many cars enter? So how many cars simply just enter the parking lot from time 0 to 12? So again, our enter was this equation E of t. And if we look at it about like the initial, it says the rate at which cars enter, right? It didn't give us anything about how many cars were in there at the beginning, but that doesn't matter because we just want how many enter. So even if there were like 200 cars in there at the beginning, it's okay because we just want to know how many came in. So the amount entered would just be the change. So it's the derivative, the integral. So it's the integral from 0 to 12 of E of t dt. So on our calculators, right, we go to this little button to the left of the book, integral with our endpoints, 0, 12, and then I'm going to just come up here, hold down Shift, and Control C, Control V, dt, and we get 520.0704. What would our units for that be? They want it to the nearest whole number. What would our units be?
Cars entered.
Yeah, cars entered or just cars. Right. Cars entered is fine too. right? So we had cars per hour before, and so we're chopping off a per time because we did an integral. All right, C, use a trapezoidal sum. This is one that A and B, in some extent might be on our exam, but I'm not sure, that we did them strictly on the calculator. I don't think they'll be asked exactly that way. They might ask us to do, A instead of the rate of change of E of t. They might ask for L of t because that's what the table, you can't, right? You can't Google it. So my thinking is, probably more likely on our exam, they would have asked for L prime of 7, which would have been, in between 5 and 9. So it would have been 24 minus 40 over 9 minus 4. You need to write this. Like, you have to write this. You can't just jump to an answer. You have to show that you did the math. You can write, L of 9 minus L of 5 over 9 minus 5. But you have to write at least one of those. Okay. And then, you plug those in. 24 minus 40, we get negative 16 over 5. And you can just leave that as our answer with cars per hour squared. I think this is much more likely what I kind of did in red for our exam. But, we'll see. They've kind of said that they don't want to do questions that are purely calculator, right? Like, you might use your calculator here to do 24 minus 40. But hypothetically, you don't need like a TI. And the reason for that, we're pretty lucky that we have the TI Inspires, that we were able to take them home, but not every student was. So they don't want to make that a requirement for this year's exam. Anyway, so for us doing this trapezoidal sum, I like to, rewrite 2 to 12 integral of L of t dt, and then with an approximate. And so we're going from 2 to 12. Be careful on the real AP exam. They don't have to start here and finish at the end, right? Like, hypothetically, they could just say from 2 to 9, and then you would just be doing these like this section. Or they could say from 5 to 12, and so then you're not using the first one and you're starting at 5. So do be careful and just look at the endpoints to make sure that that is what's happening. And then if you were watching the video, they said you do have to write this as a product and sums, right? So our width here is 3. And I like to do 15 plus 40 over 2 altogether. Like, our heights, add them up and divide by 2. In the video, they showed another way to do it where you just factor out the half, and that works as well. But I'm going to stick with the way we've been doing it all year. So this is 4. There are lots of different ways to do trapezoid rule. I've just found that this way, I like to, it kind of helps me to just keep it as a pattern of how to do it the best. So from 9 to 11 is 2, and then 24 plus 68 over 2. And then from 11 to 12, the width is 1, and then 68 plus 18 over 2. And you can actually leave your answer like that. That's fine. Just kind of box it. If you're running out of time, maybe do that. Maybe if you have extra time at the end, come back and actually write the number. If you did type all of that out into your calculator, you should get 345.5, right? And so now it says, using correct units, explain the meaning of that integral. So I'll do that in another color. We'll go with blue. So we can say the integral from 2 to 12 of L of t dt. And if this is good too, because I've seen a lot of you guys just go ahead and submit that. That does not look like a 12. So remember, someone's grading your work. Make sure it's clear. If you have a couple seconds after you take your picture, look at your picture and make sure that someone could read it. I've had a couple people submit it where I really had to zoom in, or one person I even had to like go into a filter and adjust the lighting. So just make sure as you're submitting everything that you're going back, and if something isn't readable, that you go back and you make sure it is readable. Right, it's kind of a balance between going as fast as you can, but also making sure it's gradable. So 2 to 12, remember, L of t was the rate that cars were leaving. So if we take the integral, the rate that they were leaving, the integral of the rate turns into the amount that has left. So it's is the number, or the amount, if you want to say, of cars that leave, or you could say that left the parking lot, right? Because that's what they were leaving. And then we'll say like maybe even just in cars. Technically we know it's in cars, but I'm just going to put in cars between t equals 2, and I might even just add that as is 7 a.m. You probably don't need to. And t equals 12, which would be 5 p.m. Right, because they said t equals 0 was 5 a.m. All right, probably just saying between 2 and 12 hours is probably fine. All right. D, for 0 less than time less than 6, $5 are collected from the parking lot. This is kind of a good question. It really makes sure we're understanding this. So $5 are collected from the parking lot for each cart entering the parking lot. And then from time 6 to 12, $8 are collected from the parking lot. How many dollars would be collected total? So essentially we just kind of want like some sort of like 5x plus 8y, where x is the amount entered between 0 and 6 hours, and y is the amount entered between 6 and 12 hours, right? And that's kind of what I'm thinking, just algebra 1 perspective, right? But what is x and what is y? It's not E of t, right? Because E of t was our rate, and what we just kind of thought about up here was when we did the integral of the rate, we got back to the amount. So what this ends up becoming, and everything I drew in blue is just like my thought process. What this ends up becoming is 5 times the amount entered from 0 to 6 of E of t dt plus 8 times the amount entered from 6 to 12 of E of t dt. Right? You cannot add those. They have totally different endpoints. And so you would just in your calculator kind of go back and type that in, right? And if we already have something written in our calculator, this was E of t, right? We already did this, so we can just come back up here, change this to a 6, put a 5 in front, and then make sure we go out all the way at the end, plus put an 8 in front, type it again, but change our lower limit to a 6, and we'll get 3530.13. It said to the nearest dollar, so we'll say that's equal to $35.30. Any questions on any of those, A, B, C, D? So number 2, this one is kind of more of an area question, so we're going to go ahead and skip it. And then we got number 3. I like this question a lot. I want you guys to kind of hop in the chat, maybe try it on your own. So I'm going to give you like a minute, maybe 2 minutes to just try to get an answer for A. This is no calculator allowed. Try to get an answer for A on your own. I'll give you about 2 minutes. All right, any ideas, any questions, like what confused you about this? What do we think? Either hop on the chat, or turn your mic on. Yeah, so Nathan just asking, is it just still f of 4 minus f of -3 over 4 minus -3? Yeah, that's all it is, right? Because we're not doing an integral. Average rate of change is just using the endpoints. So kind of graphically, right, if we thought of 4 as over here and -3 as being over here, it doesn't matter at all what our equation does in between, right? It can have a bunch of piecewise sections. It can have something like that. It can even oscillate, and then maybe come down to here. It doesn't matter what the rate of changes were in the middle, right? It's increasing here, then it's decreasing, has a kink right here, increases, kind of oscillates to decreasing, goes back to increasing, goes back to decreasing, all of that in between. It could have even gone, skyrocketed way up, maybe do something way up here and way down. It really doesn't matter what it does. All that we care about with average rate of change is we only care about this endpoint and this endpoint. And what was if we take all of that, you would average it out. What would be like the fastest path would be this green line, right? That's also called the secant line for this curve. And it's like the fastest way to get from point A to point B, but it's that slope is our average rate of change. So everything in the middle doesn't matter at all. We only care about the endpoint. So it doesn't matter that this had piecewise. All that matters is that we can plug them in. So for f of 4, what does matter is f of 4, are we plugging it into the top equation or the bottom equation? Well, 4 is down here in like the 0 to 4 section. So for f of 4, we're going into this, right? So make sure you use parentheses, right? -4 plus 3 cosine of 4 pi over 2. And I would definitely write this, even if you're going to plug it into your calculator, just to show the grader that you knew where it was coming from. And then f of -3, that's going to be right in this top section. So in parentheses, 9 minus 3 squared, right? Even though this was a non-calculator question on our exam, we'll be able to use our calculators. 4 minus -3 is 7. And you can leave your answer like that. We'll go ahead and simplify this really quickly. The cosine of 2 pi, right? That's the same as the cosine of 0, which is 1. So that's -4 plus 1 minus, and then the square root of.
Don't you have to multiply by 3? Because of the...
Yeah, thank you. I knew I was messing something up. Okay. -4 plus 3 times 1. And minus the square root of 9 minus 9. Right, so square root of 0 over 7. -4 plus 3 is -1 over 7. So it was a little bit tricky, but definitely, I think, doable. Part B says write an equation to the tangent line at x equals 3. I'm going to just copy this so we don't have to keep scrolling up and down, because we will keep using it. All right. So here's our equation. So anytime we see tangent line, we're immediately thinking x1, y1, and m. The exception to that is if they just say the slope of the tangent line, right? If they only ask for the slope of the tangent line, then they're really just asking you for the derivative and to plug it in, plug in the point. But here we want the equation. So x1 is 3. For y1, we're going to plug in f of 3. Well, f of 3 is in this bottom equation. So that's negative 3 plus 3 cosine of 3 pi over 2. Right? 3 pi over 2 is down here. So that's 0. So we just get negative 3. Right? For cosine, right? This is 0, negative 1. So it's 0. And then m is the slope, the derivative. When we're doing the derivative, f prime of x, technically you can have a derivative for the top equation and for the bottom equation. But since we're only concerned about at 3, right, at x equals 3, right now we only need to worry about the bottom equation. So in our bottom equation, we have negative 1 plus, and I'm going to actually change this to minus, and the reason I'm going to change it to minus is the derivative of cosine is negative sine. So minus 3 sine of pi x over 2 and times pi over 2. I'm going to write that a little bigger for us. So negative 1 minus 3 sine of pi x over 2. And the reason times pi over 2 is we have to chain rule, right? This is the cosine of box. So the derivative of cosine of box is negative sine of box times the derivative of the box. And for pi x over 2, right, that's like just pi over 2 is a constant times x. So its derivative is just pi over 2. Again, you guys all have a calculator. So my recommendation is just do that derivative on your calculator. Okay, now for m, right, this was f prime. For m, we're going to need to plug in 3. So for m, we're going to plug in 3, negative 1 minus 3 sine of 3 pi over 2, which we showed would now be negative 1 times pi over 2. So that's negative 1 minus 3 times negative 1 times pi over 2. So that becomes negative 1 plus 3 pi over 2. And we can leave our answer like that with the 3 pi over 2. So now our equation will become y minus y1, which is negative 3. So I'm going to write that as y plus 3 equals, and I'm going to put this whole slope in parentheses. And then x minus 3. A lot of you guys, I know just from looking at your work over and over, a lot of you guys would have forgotten this parentheses I'm putting in red. And you will get that question wrong. Okay, that parentheses needs to be there. Even though normally we think it as y minus y1 equals m times x minus x1, there is no parentheses around m. It's because m is usually just one number, right? But because we have a plus here, right, negative 1 plus 3 pi over 2, we need to add this parentheses. So if you had just written it like this is wrong. Okay, that's absolutely a wrong answer because it's missing that parentheses, and essentially you're only multiplying x minus 3 times the 3 pi over 2. You could add the 1 over, and this 3 would have became 4, but we know it's not 4. It's minus negative 3. So just being careful on that, right? You need to have that parentheses.
Viewer, I have a question.
Yeah.
You know how like normally when we write our tangent lines, we leave it as like the y plus 3 equals whatever. We could just leave it like that because I know like in the FRQs and stuff, they always like move the 3 over and like.
Yeah. So in the FRQs, and it's the same thing that I've kind of been telling you guys about this stuff up here where this is a valid answer that I boxed up here, right? You don't actually have to get to 345.5 or, right, this 29 minus 40 over 9 minus 4, that I circled is actually valid. You don't have to ever get to negative 16 over 5. We could have, now we do need the units, but we could have just written 29 minus 40 over 9 minus 4 cars per hour squared. On the AP exam, they're not asking you to simplify unless they specifically state that you must. So if they said, write an equation for the tangent line, this is an equation. We're done. Now, if they specifically somehow said, you were reading and it says solve for, y equals on the tangent line, then yes, you would need to subtract the 3 over. But with tangent lines, I don't think I've ever seen them do that. The one time where they really want you a lot of times to solve for y equals is on those dy dx equals like x plus 2 times y, where you like move the y's over, the x's over. A lot of times on there, they'll ask you to solve for the y equals solution. But with tangent lines, this is totally valid. What they do on the FRQs on those answer keys is they like to simplify it all the way. But when the graders are reading it, they'll have a list of all of these different acceptable answers. And if it looks like your work is correct and you have something a little different, then they're going to go and check that it is the same, right? Here we had -1/7, and I boxed that, but this actually would have been correct. And actually, this would have been correct. So you would have gotten points if you just had this, points for this, or points if you had simplified it all the way. And so it's the same thing with this equation. Okay, moving on. This one is definitely a little tougher. Find the average value. Let's come back and grab this again. Thought it was going to stay copied for us. So find our average value. Okay. So now with average value, what's our formula for average value? It's 1 over 4 minus -3 integral from -3 to 4 of f of x dx. Now, with our average rate of change, it was just points. It was f of 4 minus f of -3 over 4 minus -3. So since it was just at points, we could just plug it into the bottom and plug it into the top and not worry about splitting anything up. But here with an integral, we do need to split this up. So what's going to happen is this is 1 over 7, but we can't do the integral from -3 to 4. We can only do the integral from -3 to 0 of the top equation and then split it to 0 to 4 of the bottom equation. So just make sure you don't forget about this 1/7. I've seen some people do it off to the side. The 1/7 needs to go to both integrals, right? Because it's going to this. So maybe make a big parentheses, right? This becomes the integral from -3 to 0 of square root of 9 minus x squared dx plus the integral from 0 to 4 of -x plus 3 cosine of pi x over 2 dx. And again, this is just a, at this point, plugging it into a calculator. Technically, yeah, here, the integral of the -x would be like -x squared over 2. This part we would do u sub on, right? Like u is pi x over 2. So du is pi over 2 dx. So we'd have to multiply by a pi over 2 and a 2 over pi outside. And then this guy's integral is actually a little bit harder. And you get it because this is the equation of a circle with radius 3, right? And it's just actually the top half of the circle. because of the square root. So you can do that with area. But we're not going to worry about any of that because we're going to have calculators. So even though this was a non-calculator question, I'm going to just say here we have a calculator because that's what's going to happen on our exam. Now, the one thing that we do need to make sure we watch out for is just that 1/7, right? So the integral of the first part is going to be 9 pi over 4, and the integral of the second part is going to be -8. And so we need to make sure we have that 1/7 there as well, and it's multiplying to both in parentheses. Okay, part G says, must there be a value at which f of x attains an absolute maximum on the closed interval from -3 to 4? This is a pretty good question to look at. I honestly wouldn't be surprised, especially given that this was on their practice exam for this year, and it's a question that can't be Googled. Normally when we see this, must there be a value? So far I've been telling you guys IVT and MVT. And I guess it's kind of because this last one is so so rare, but there is another one called extreme value theorem, right? I guess EVT. And we talked about this briefly, but essentially what the extreme value theorem says is that if you have a graph from, say, A to B, if your graph is continuous, right, then somewhere there's going to be a maximum value. We don't know where, but somewhere there's a maximum value. In this case, it's here. And somewhere there's a minimum value. In this case, it's here. But it's basically just saying if, kind of if and only if, f of x is continuous over A to B, then f must have an absolute minimum and an absolute maximum in the interval from A to B. So if they say, must there be like, an f prime equal to 0, right? That would have been MVT because we have f and it wants f prime. If it said, must there be an f of x equal to 0, just f, then that would have been IVT because we have f and it's f. If it says, must there be an absolute max or an absolute minimum, that's actually this extreme value theorem. And so what this question is actually kind of doing is it's a way to both test that you can connect that extreme value theorem and that you can prove that it's continuous. Because what was the condition for extreme value theorem is you had to show that it was continuous. So that's something I think good for us to go over. And I would not be all that surprised if they threw that on our AP exam, and then hopefully we're ready for it, and maybe a lot of students, other students are not as ready. So we'll see. So anyways, how do we show that something like this is continuous? This is where I was talking about the other day. Right, I said Carlos Garcia did a really good job of just using Roman numerals and really showing this that way. So step one, right, write the limit as x approaches. Now, we know it's continuous here, and we know it's continuous here. So the main issue is it continuous at 0? If we can show that it's continuous at 0, then it's going to be continuous the whole way through. So that's what we're checking, is where it changes. So the limit as x approaches 0 from the left. And you can either write f of x, or you can write, the square root part. I'm going to just write f of x. And then I'm going to write is equal to, and so the left side is going to be this top. So I'm going to write is equal to square root of 9 minus 0 squared. Square root of 9 is 3. I know technically plus or minus 3, but with functions, you just go with, if it's an f of x, and then we have 9 minus 0 squared, you go with positive 3. Or if it looked like that, then you would go with negative 3. You can't have plus or minus for functions because it wouldn't pass the vertical line test. So when we have a function, right, essentially what I was saying before is that if we have f of x equals square root of 9 minus x squared, this is the top half of a circle, right? And f of x equals negative square root of 9 minus x squared, that's the bottom half of the circle. And it can't be a function with plus or minus because it would fail the vertical line test. So we're just going, even though it was technically plus or minus 3 with math, right? If you ask a question like, what is the square root of 9? The square root of 9 is plus or minus 3. But if we have a function that we're solving for, you can only have one, otherwise it doesn't pass. Okay, now when we're solving for x, right, like if we have x equals the square root of 9, then that's x equals plus or minus 3. Because x is not a function, it's a point. You can have positive 3 and negative 3 as our points, if that makes sense. All right, so anyways, that was a long explanation about that, but now we have the limit as x approaches 0 from the left. Limit as x approaches 0 from the right, f of x. This would be the negative x, so negative 0, which is just 0, plus 3 cosine of 0, like pi times 0 over 2 is just 0. So this just becomes 3 because cosine of 0 is 1, 0 plus 3 is 3. Now, what we want to say is because of these two things, we can kind of put it therefore the limit as x approaches 0 of f of x equals 3. We want to make sure we write that line because when the left hand and the right hand are both 3, that means the overall is 3. We don't just want to put that exists, we want to put that it's equal to 3. If you want to add the word exists, great. You don't actually have to, but what you have to do is show that it was 3. Okay, number 2 is now to do f of 0. And just write f of 0, which one is it equal to? That's where it is. So equals, you can just write the same thing we wrote up there. Okay, so it's equal to square root of 9 minus 0 squared equals 3. And if you want to write then exists, great. Now number 3, this is like our main key thing, is now we're writing that part A, the limit as x approaches 0 of f of x equals f of 0. And they can see that you knew they were both 3. But I like to just even add on to it that 3 equals 3. And then we're going to put therefore, this is our main thing, therefore f of x is continuous at x equals 3. Now, that's if they just asked us for continuous. But when we go back to this question, it wasn't. It was saying, must there be a value that it contains a maximum? So I'm going to put this in another color because this is like our main big thing. So we can now say that because f of x is continuous, not necessarily at 3. Oh, wait, this should have been a 0. Right? Make sure you do that. The at part is the x value, not the y value. So because f of x is continuous, and not just at 0, but over this entire interval, so over negative 3 less than or equal to x less than or equal to 4, right? There must be you can just rewrite this, there must be a value of x at which f of x attains a maximum. And if you want to just kind of say there must be a max, that should be fine. I'm just, if you have extra time, rewriting what they wrote is always good. And then the key here is by the extreme value thing. So the key here was that we wrote f of x is continuous, and then we wrote that it has an absolute max and by the extreme value. So I know that's a lot of work, but you know, it just kind of is what it is. All right. Moving on, number 4. This is a weird question, or weird looking graph, but it's just that same thing we've been doing this whole time. We see g of x. So immediately, we want to make sure that we're writing that g prime of x equals f of x, and that g double prime of x equals f prime of x. This might be some point somewhere, and we definitely are going to need it for justification purposes. So information they gave us, they said it has horizontal tangent lines at -half. So we know that that x value is -half. At +half, so that x value is +half. And at 5/2. So that's 5/2, half, and -half. Then it also said that it is known that f of x equals -x squared plus 5x minus 4 between 1 and 4. So we know that this between 1 and 4, that's the -x squared plus 5x minus 4 portion. And it says the areas of region A and B are 3 and 5. So we know this area is 3, this area is 5. Find g of 0 and g of 4. So for g of 0, right, that's going to be the integral from -4 to 0 of f of t dt. So that's going to be from -4 to 0 will be this area. That's a big triangle. You don't have to split it into two. It's just one big triangle. And then the A. And because we're starting at -4, we're always going to go left to right. So everything above is positive. Everything below is negative. So that triangle is 1/2 times from -4 to 1 is width of 3 and height is 3. So that's 9/2, right? And then they said the area of A was 3. And because it's below the axis, we're going to make it -3. So 9/2 minus 3, that's a perfect answer. Right? If you want to simplify it, you can simplify it. You'll get 3/2. Right? 6/2. G of 4 is a little bit harder because for G of 4, we're going to have the integral from -4 to +4 of f of t dt, which is going to become, now I can actually keep, right, we already got to here. Does that make sense? We already got here. So we can actually keep this as 9/2 minus 3 and then plus 5 because the area of B is now 5. And now it's going to be plus this last section. So it's going to be plus. Now for that one, they didn't give it to us, but we have this formula. So it's going to be plus the integral from -1 to 4 of -x squared plus 5x minus 4 dx. You can do this by hand. We have calculators. I'm going to just do it on my calculator. And when you do it on your calculator, you end up getting an overall answer at the end of 11. So I just type this whole thing into my calculator. 9/2 minus 3 plus 5 plus that integral, and we get 11. Okay. I'm going to kind of skip that. You know, I think we can handle typing things in. Okay. B says find the absolute minimum of G. Now, a lot of you guys just jump straight to the table. If you jump straight to the table, you just lost a point. Okay. You need to make sure that we write G prime of x equals 0. And I like to write even G prime of x equals f of x because that's our graph equals 0. That's always going to be 1 point. Okay. And in this case, they actually gave you a point for, they really wanted to see G prime of x equals f of x. Right? So now we do our kind of candidates test with x and G of x. So we're always going to have our endpoints. And then our other candidates are going to be wherever it crosses 0. So it crosses 0 at -1, at 0, and at +1. Okay? And then to get our answers, we're just going to plug into our equation. So g of x equals the integral from -4 to 0 of f of t to t. Well, -4 to -4, that's going to be 0. For our -1 section, right, to get to -1, that's just this top triangle, which we already solved, and we got 9/2. For 0, we already solved, and we got 9/2 minus 3, right, which I'm going to just write that as 6 over 2, so 9 minus 6 is 3 over 2. For +1, we didn't do that yet, but it's going to be adding on 5, right? It's going to be this previous answer adding on 5. 3/2 plus 5 is like plus 10 over 2, so that's 13 over 2. And 4 we just did, and we got 11. So we want our absolute minimum. Well, all of these guys are all positive, so the absolute minimum ends up being 0. So we'll just write our absolute min is 0 at x equals -4. Right, could we do a number line and justify getting rid of some of these points? Yes. But where I need you guys to be careful if you are going to go that route, I would really just recommend doing the full table. You can't lose any points if you do the full table. You get them all. If you did do a number line, g prime is f, so it's just the positive and the negative sections. So see, this is positive, and it's only negative between -1 and 0. So that's the only negative section. So if you did this number line, what you would have to kind of do is you would have to say it's increasing, decreasing, increasing, increasing. So we see that 0 and -4 are only candidates for minimums. So you would have to explain that by kind of explaining your you can't just write that. You'd have to say like x equals -1 cannot work because g prime equals f is positive for -4 to -1. And then you'd have to similarly explain why 1 and 4 can't work the same way. So I don't like doing that. I like just doing the full table. Okay, for all intervals, find all intervals where g is concave down. So again, I like to just kind of say that we have g prime of x equals f of x, and for concave down, it's where that is decreasing. So where is our graph decreasing? It's decreasing between -2 and -1, between -1 and -1/2, from 1/2 to 1, and from 5/2 to 4. So if we kind of look at this as well, this is a kink, but it is kind of fully decreasing that whole way. So I'm going to kind of combine those two. If you wrote them separately, that should be fine. So I'm going to say g is concave down for -2 to -1/2, union 1/2 to 1, union 5/2 to 4. And if you wanted to do the whole like -2 less than x less than -1/2, that works as well. Because, and I like to write g prime of x equals f of x is decreasing on these intervals, or over these intervals, however you say it. And that would be full points. Any questions about that one?
Could we also say, because technically, like, if we were to create a graph of g prime, it would be like less than 0?
You can't say g prime is less than 0, right? G prime of x equals f of x is decreasing. That's my preferred way to do it. Now, you can say g double prime equals f prime is negative. But my issue with this, and sometimes graders' issues with this, is how do you know it's negative, right? It's negative because f of x was decreasing. So to me, this is the best way to explain it. But technically you should get points if you said G double prime equals F prime is negative as well. But you got to be careful with, right? G double prime is negative. That means F prime was negative. And what they're really looking for here is they're looking that you're connecting it back to the graph of F. So that's why my preferred way is this way I did in blue. Okay. Kind of just looking through 5 and 6. I'm not going to solve all of them, but we'll kind of just actually we'll save 5 and 6 because I don't want to cut them short. So I'll save these. We'll try to hit them tomorrow as well. So what I am going to have you guys do tonight for homework, kind of two things, okay? You know, I'm going to give you guys a little bit more homework just because we do have not a whole lot of days left. So kind of we have two things for homework tonight. Number one is going to be, I want you guys to watch the mock video review where they go over that mock yesterday. I did post some notes about it. I thought it was pretty difficult, but you know, talking to some of you guys, just making sure that we know that, hey, it's supposed to be difficult because an actual 50% is going to be passing. So, you know, that means you literally failed the test. You only got half of the questions right and you still passed. That's a hard test, right? So it's supposed to be hard. It's just a matter of getting points where we can. So that's that. So you're going to watch the mock video, and then what you're going to turn in is I'll have an assignment where you turn in your corrections. Okay, so you're going to kind of correct anything you got wrong. And then our second homework is going to be this kind of you gotta know thing. And these are a lot easier. These are kind of like our basic stepping stones. So just this is for any graph questions. These are all of the things that you should know. Where is it increasing? Justify. Where is it concave down? Justify. Where does it have an inflection point? Justify. Where is it concave up and decreasing? Justify. Right? And then going into some of these other things, even evaluating a limit down here, right? And when we see limits on our free response, we're probably kind of jumping ahead thinking it's probably going to be a 0 over 0 L'Hopital's deal. But these are, you know, not necessarily absolutely everything that they can ask, but this is kind of best guess at everything they might ask about those graph type questions. The next one is just kind of a table with that table context question. What might they ask you? So, you know, Riemann sums, average rate of change, everything, you know, we might want to do. These explain why there must be a value questions, IVT and MVT stuff. All right, and then this one's a little bit different. It's still a table, but this is more of like into that other, where we're looking at, you know, chain rule, quotient rule with a table, right? FTC with a table. So that's kind of more of that, almost like that other section. And the last one is differential equations. All the stuff that we absolutely needed to know with differential equations. I didn't put any motion velocity stuff on there because we went over that yesterday. So I kind of wanted you guys to do this. And I want to ask you guys who are here, I do have an answer key made for this, but do you think it would be more helpful to wait on the answers until tomorrow and go over it? Or do you think it would be more helpful to have the answers The main thing is this is important for you guys to do on your own. I don't want people to just be copying the answers. So kind of being honest with yourself. Do you think that it would help you more to have the answers or to wait and review it tomorrow? Like you would be too tempted to cheat. Okay. Nathan, you're getting outruled, but here's what I'll say is I'm not gonna give you guys the answers, but if you know that that's just the way that you work, like that it's gonna be more helpful for you to have the answers and to kind of check as you go, then you can email me and I'll send you the answers early. But um, otherwise you don't have the answers. So um, those are 2 homeworks. And like I said, for number 2, if you send me an email, I'll send you the answers early. Otherwise, you're trying this without. And yeah, Nathan, quit your job. You can tell him you're quitting until next Wednesday. You'll be back Wednesday. All right. Watch they schedule you for next Tuesday.
Bro, I already missed a couple of days. Man, I can't miss no more.
All right. You're like taking the AP exam like while flipping burgers. So anyways, that's it for today. Thanks guys for being here and let me know if you have any questions on that. I don't think the homework should be too hard. But this one, it is definitely a lot of questions. So it is kind of time consuming that one we just looked at. So make sure you start it early because it will be like I said, it's not hard, but it will be time consuming. All right. So with that, we're done for today. I'll see you guys tomorrow.
Are you gonna post this recording?
I can. You want me to?
Yeah.
Okay.
Thank you.